Let's quickly install R and RStudio. To do so, visit this link for R and the second link for RStudio. I am taking you to an Chrome window where these links can be obtained, and then we can install R and RStudio. If you open a blank tab and type this URL cran.r-projects.org, it opens this page where there are options to download our software based on your operating system. Since Windows is what many of us use, so I'm clicking here. Once you click Windows, it will download a file, and that will go to your download folder. Followed by this, there will be the second link that we can open, www.rstudio.com, which then takes you to this page, and you have the option to download RStudio. Click here and you get download RStudio tab here. Once you click, you will get a installation file downloaded on the local system. And let me now therefore share the download folder in which this R installation file and this RStudio installation files are there. Double click on the R and follow the instructions. The default options can be chosen and it will install R in your system. Similarly, double click on RStudio. You may have to allow the software to be modifying local files and so on. So just follow the instructions and it will install RStudio in your local system. Once it is installed, the desktop will contain a icon like this, which will be for R, and RStudio you can find from your system by going to the Windows tab and then typing RStudio. It will show an icon like this, and then if you click, it will open the RStudio. Now I am showing first how R console looks like. So I'll open R console and go to view how it looks like. Let me show R as a console. So this is the R console. It's kind of a black box where you don't see all the information up front. So it's quite confusing for new starters if you have to work only with R. So therefore, RStudio is more user-friendly in understanding what is available in your environment, what commands you have, what results you have, what graphs you have, and what variables and data you have in your R environment. So for that, we go for RStudio rather than R, although R can still do the same thing, but the visualization is not very appealing to new users. But the same thing can be done in R also. So now let's see the difference, how RStudio looks like. Once you open RStudio, its look and appearance is something like this. So here you have 4 different windows. The console is here, this left lower corner. Here is your R script, and that can be written and saved, and those commands can be run depending on what you are analyzing, and it can be saved and it can be rerun at a later time also. Then you have an environment where your data frame and your variables can be stored, and you have help window here, and it can also display your plots that you can generate from your data. So just to illustrate, let me generate some random numbers and plot it. And for the sake of convenience, I shall take random numbers from a normal distribution. So let me say that a variable, say rand norm, I generate using rnorm function, which is in R, and here you can basically say how many numbers to generate. Let's say 1000 numbers, and the numbers come from a distribution which mean 0 and standard deviation of 1. So you will see and notice the output of the command that you has run. For example, how to run it, you can keep the cursor here and run it. So it just rewrite if you run it multiple times. So you have 1000 numbers, and it can also be seen. For example, if you type list the variable and run this command, you will see 1000 numbers in the console, right? So this is how 1000 numbers were generated. Now this is not in any order, right? Now it can be plotted. It can be plotted just by means of a histogram, for example. So for that, suppose you can write hist command and histogram of which variable, rand norm, and we can simply go by default frequency instead of our own. So you have a histogram, therefore generated, and usually a standard normal variable will have most of the values between -3 and +3, and that's what we see this histogram uh, to be resembling a normal distribution. But then some density function or density curve can also be generated from these random numbers, and we can also generate the cumulative density uh, of the normal distribution based on the sample 1,000 numbers. Of course, it looked like a normal distribution, both in case of density and in the case of cumulative density. So with that, it requires you to use a couple of other functions. For example, we can generate the density using the norm function, the norm of my numbers which are available under rand norm variable. This will generate the density, but let us give it a name. For example, rand then is the density of these numbers, for example. So we can run this, and it has created some sort of other numbers that will give you density. Now, notice the difference between random number and random density. Density can be positive, whereas random numbers can be positive or negative. If I want to plot the numbers against its density, it can be simply plotted the numbers in x-axis and density in y-axis. And if you run this, you see a nice looking normal density. And again, it is based on those 1,000 numbers that were generated in the beginning. Now, the last thing I would show here is the cumulative density. For that, we use pnorm function in R, and pnorm of what? Pnorm of the random numbers, and again it was generated from a mean zero standard deviation 1 kind of distribution. And let me give it a name. Cumulative is a name given to this cumulative density, and once it is run, it is creating one more values here. Now the cumulated values will be something between 0 and 1, because cumulative probability will touch 1 eventually. Now, it can also be plotted against the original random numbers. Say you can create a cumulative plot of these numbers, and what is the cumulative density as the numbers are changing, right? So you have cumulative in the y-axis and the numbers in the x-axis. And once you run this, you see a cumulative density. So this is how basic use of R can be made with some statistics. There are a lot more things to do, which are either similar to this or subsequent to this. We'll see that in subsequent sessions. Hope you liked.